Bas drives our labs team that incubates a lot of the innovation and makes sure it lands with our mainstream development teams and gets into the product. So please welcome Bas.
Good morning. Thanks, Christian. Thank you. Good morning, everybody. So, good to be here after 3 years again. Today, I want to show you some of the new innovative capabilities we're bringing into the product in IFS Cloud 22R2 or even beyond in 2023. And for that, I want to take you on a little journey. Meet ATSG. ATSG is one of our aviation customers down in Ohio, and they're actually one of the leading providers of aircraft leasing and air cargo transportation. You might not immediately recognize their name, but I want to bet that many of you have ordered something through Amazon Prime. Chances are really high that that parcel has actually been transported with one of their aircraft. The business process that I'm going to show you is inspired on a real-life situation that they encounter in their day-to-day operations. And although it starts with aviation, it's applicable to all industries. So, as soon as an aircraft returns from a flight, it needs to be inspected. We're using the IFS Flight Line Maintenance app to do that. And then, if we discover something needs to be replaced on the aircraft, we can leverage the supply and warehousing capabilities in IFS Cloud to support that. After the part has been replaced and the aircraft is operational again and the passengers fly out to their nice vacation destination, we need to ship the damaged part back to our connected factory. And a factory needs power. And in this case, it's powered by a sustainable energy source, wind. And after using predictive maintenance to identify possible failures or decreased performance, we need to send out a technician to the wind turbine to actually perform the maintenance. So again, today I'm going to take you on this journey. Let's head out to the airport, receive the airplane, and we're going to do that by using IFS Flight Line Maintenance. One of the new capabilities we have added in the IFS Flight Line Maintenance app in the release 22R2 is the ability to measure objects or damages with the help of LIDAR that is available in modern devices like the iPhone 14. It's really focused on an increased user experience and an increased higher level of traceability of damages. But, well, for those of you that have seen me before, let's just see this in reality. So, let me pick up my iPhone, go to my work. I see I have to inspect the damage on the right cabin door of the airplane. So I click on that. I walk over to my airplane door. Sorry guys, we couldn't fit in an actual 777 door because that's too heavy, so I took a little bit smaller version of it. So and what we can see immediately, there's a big damage on the door. So what I'm going to do is add a measurement. Click on that. It's the length of a crack. And rather than me taking a tape measure out and measure it, I can actually just click on this icon, and it's going to use LIDAR to build up a model in its memory of its environments. And actually, I can just say, I want to measure from there to there. And as you can see, I can take a nice little picture. And this picture automatically gets added to the work task. I click on OK, save. And the value has been added into the system, accompanied with an actual picture of the damage. So next time around I'm doing this inspection again, I've got all the historical data at my fingertips. Now, as is obvious from this, let me quit my clicker again. The conclusion is clear, right? We need to replace this door. So let me walk back to my workstation. That's here. see if it's still awake. There we go. And what I'm actually going to do is make a material reservation for a new door to get that from the warehouse. And that's actually just a simple transaction in IFS Cloud. I just click on Reserve Material. And I say, OK, I just want to reserve one of it. Click, save, and it's there. And actually doing this gives me a perfect opportunity to talk about another technology, e-paper. And e-paper we probably all know from our Amazon Kindle or Kobo e-reader. It's a technology that allows you to digitally display data, but the technology is low in energy and at the same time relatively high in capability, and you don't need to cut down any trees for it. It really is suitable for that sweet spot that sits in between printing paper and using high-end devices like tablets or TVs or iPhones. But let me give you an example. I actually got a little warehouse on the stage as well. And in this warehouse, I actually have a couple of shelves, bin locations, and one of them actually has some data about the transactions we were going to do. So the moment we made the material reservation, a signal or a transaction has been sent directly into the warehouse to the right bin location to say that this part in this box is actually reserved for our cabin door 737 for the right pick list and the right task. So the moment I do the transaction in my ERP, the data is immediately reflected on my warehouse floor. Now, it also has some interaction. So if I click this button, and it takes about 10 seconds, right? Like I said, it's a little bit less capable than an iPhone. At the same time, it's more capable than paper. I don't have to put out my gun to scan the barcode, etc. But within 10 seconds, the actual transaction has been processed and sent back into the ERP, and the material is now taken from the bin location and put in a handling unit. And that gives me another opportunity to show that you could use this for handling units as well. So the data is also updated on this handling unit label. And it says, again, this door is reserved to replace the damage on our airplane, the right task number, where it needs to be brought to, and all the information is dynamically updated directly from the ERP on the device, hugely helping user satisfaction or user experience. So, next step in our journey. The door has been replaced. It has been removed from the airplane. It needs to be repaired. So we're going to ship it back and repair it at our connected factory facility. Coincidentally, that factory facility is nearby as well. And Christian talked earlier today about using technical innovation to drive functional innovation. And a great example where this is applicable in the investments we are making in the product is the connected factory investments we're making. To us, to IFS, the connected factory has 4 important aspects. 1, using planning, scheduling, and optimization to utilize critical resources and optimize your production plans. 2, real-time machine integration to orchestrate the shop floor directly, reducing the need for additional third-party systems. 3, collecting the data from the machines to predict when machine performance or product quality will degrade, basically applying asset performance management on the shop floor. And lastly, use that to optimize your business by, for example, running what-if simulations to enhance your production scenarios. As said, the factory is nearby. So, make sure I've got everything ready for you guys. Let me give you the overview of this factory. And what we see here is a real-time lobby that shows everything that's going on in this factory. But instead of just looking at the lobby, let's also look at the actual factory. And this factory is actually located down in the innovation area on the exhibition floor. And what we see on this factory, we see on the bottom, we see a 9-bay warehouse with different bin locations. We see some robot arms that are automatically taking the material from the warehouse and putting it into the production line. And we see a production line that basically has 3 stations: a painting station, a coating station, and a quality inspection station. And what we see on the screen is that a bunch of shop orders have been created based on our demand, based on the work we need to do. And we see that a product is currently being brought through the production process. So that's likely order number 498 that we see on the top, that it's currently being worked on. And if we go to the second page, we actually see it also created not a production order, but a repair order. And that repair order is basically the repairing of the door that we removed from the airplane. It's currently scheduled last, and that's probably got to do with the fact we have a lower SLA on it, or there's less priority to it, but basically all that input is taken to create an optimal shop order plan. Now, manufacturing scheduling optimization is basically based on the same capabilities as we have in our planning scheduling optimization tooling for service. That basically means that all the benefits of utilizing your critical resources, identifying bottlenecks, resolving them, are all applicable on the shop floor now as well. So let's zoom in to that a little bit more. And I go to my visual shop order planning. And I see that the shop orders we saw on the previous page are actually all on year scheduled in the most optimal order. And we see that the one at the end is a little bit larger one. That's actually the repair. So likely it takes more time because we need to scrub it first or take the old paint off or something. And probably therefore the engine has put it to the end because we could, it's less beneficial for us to do that first. Now, the same real-time integration that we're actually using to send these shop orders directly to the machines on the shop floor, we can also use to collect data from the shop floor. So let me go to the next page I want to show you. All this data we can actually collect, and we can use that to predict the quality of the products we are producing and the process that we're running. It's basically, like I said, asset performance management on the shop floor. Now, the benefit of what we do in IFS Cloud is that we can leverage, in the end, the same asset performance management capabilities within the connected factory as we can do with any other asset, like wind turbines. And we said earlier, right, that we also need to power our factory. And we're doing that with green, sustainable energy. Luckily, we also have a wind turbine nearby our factory. And earlier today, we talked about enterprise asset management. And like I said, right, wind turbines are assets. And an important topic within enterprise asset management is asset performance management. And again, to IFS, this is based on 4 pillars. It's collecting, centralizing, and visualizing the data by automating the data capture. 2, it's using machine learning to predict and highlight anomalous asset behavior, which may lead to failures or decreased performance. 3, it's then optimizing which maintenance tasks need to be performed and in what order to maximize reliability and minimize cost. And lastly, again, it's then enhancing the business by, for example, analyzing your overall equipment effectiveness. Now, let's get back and look at the wind farm. So, here I start with an overview of all my wind turbines, but in a geographically oriented map. And what we see on this map is that actually turbine 13 is red. And that indicates it probably has some sort of a critical problem which has it completely stopped. But the one I'm actually interested in for this demo is the orange one, turbine 2. Turbine 2 still has a reasonably good health, but it's not stopped. So that indicates that although there's nothing wrong with the turbine now, there might be something wrong with that turbine into the future. So let's zoom into that turbine. And what we see on this page is we're gathering all kinds of IoT alarms, unplanned maintenance events, all kinds of IoT sensor data on the left. But what we also see is that in our predictive maintenance capabilities module, we have 46 detected anomalies in the past period. And what we also see next to that, in this box, is that it's already issued a prescriptive work order to investigate this gearbox, because we're predicting, or we're likely predicting, it's going to degrade its performance to a point that we want to prevent from happening. So we take a step further and actually look at our gearbox analysis. We see again, we're collecting the same IoT data, the same alarms. But what we're also doing on this page is actually showing the gathered IoT data over the past period and using that to do anomaly detection, doing trend analysis, time series analysis, all kinds of other algorithms. We see that the gearbox vibrations, which is the blue line, are set against the gear bearing temperature. It's actually the other way around. Gear bearing temperature is blue, vibrations are green. And not every peak in the vibrations might actually be an anomaly, because we also see wind speed in there. And if you can imagine that if the wind goes faster and faster, more vibrations are actually seen in the actual turbine. So that's not necessarily an anomaly. So that the algorithms really pick out the actual data anomalies and start using them, put them in time, and start predicting. And what we see is we see closer to where we are today an increased number of anomalies actually occurring. And our algorithm has predicted that if we don't do anything, the number of anomalies will continue, and it will actually take the health of the asset down below a level that we deem acceptable. And to prevent that from happening, it actually has created a prescriptive work task to actually prevent this from happening. Now, this is a nice segue into the final bit of my presentation. We have this prescriptive work task. We need to send a technician out to actually start repairing the wind turbine. So let me conclude with our maintenance and service execution. And one of the strategic investments that we as IFS are making in 2023 and even beyond is something called intelligent knowledge management. It's the capability to take data that sits in IFS Cloud, combine it with data from outside of IFS Cloud, manuals or other sort of data sources, both structured data as unstructured data, and all combine that to make predictions and suggestions. Well, I think I can better explain this with another example. So let me go to the next demo. So what we see here is a work task. And in this work task, in the description, we see that it's an automatically generated work test based on a bunch of alarms, IT ratings, and anomaly predictions. And the system, based on the templates it has already said that to handle such an issue, there's a number of things I need to inspect. I need to do an internal inspection, a winding inspection, a bushing inspection, all kinds of inspection. But what's more interesting is we see in the bottom the knowledge search results. So based on all the data that's in this work task, the asset type, the IoT readings, it has looked in its historical data sets and starts bringing together tasks that have similar data patterns, that could be similar to the problem that we look at now. But what we also see is that the match percentage, all the way in the bottom, and I realize that that might not be visible for everybody, is still quite low. It ranges between 60 and 80% reliability. If I step through my inspection, and as I'm inspecting the windings, I actually notice, as the technician in the field, that I see a flash mark on the core of the turbine. So what I can do, now copy paste this, I can actually add my own observation as an additional data point into my work task. And as we put that in the system, it will take that additional information, put it back into a knowledge search, and starts narrowing down the actual possible causes of this problem. And we see we have 3 similar problems in the past, and they were all winding failures. And they have a much higher percentage in the bottom, 90%, but basically it says, okay, based on this IT data, the asset type, and the fact that the technician saw a flash mark on the core, it's very likely that this is the issue. Now we can do something more, because as I'm doing the repair, oh, sorry, I want to go there first. So in the service manual, it's not just work tasks that it shows, it also shows service manuals, right? So it's more different types of data that it brings back. But in the service manual, I actually see that I need to do something more. I also need to set the power correction for the winding. And now I'm like, okay, I don't know what that is. So I can add a natural language question to this. What is the winding power correction factor? And as I do that, the system is going to take the context, so everything I have in the description, the asset type, the work task, and is using that to even further down and narrow down its search into the data. And then it comes back with, hey, there's a manual uploaded in the system, and in this manual on page 97, there's actually a table for the wind power correction factors. Use this. And you can imagine that this is really valuable if you have technicians out in the field that want to take the knowledge that's already in the system, take that out and leverage that to do their work better, increasing first-time rights, reducing service visits or service time. Now, today, I've shown you a quick peek in 5 new innovations we're bringing into the product in 22R2 and 2023. It's about LIDAR, e-paper, the connected factory, asset performance management, and intelligent knowledge search. These all illustrate how we embed technology-led innovation into core industry processes supported by IFS Cloud. Thank you.